Bienvenidos, Hushamdeed, and welcome to this HUD 8 Consulting Enterprise Networking Security and Automation CCNA version 7 techtorial video. In this video, we're going to be covering Packet Tracer 5.1.8, where we're going to again be looking at configuring numbered standard IPv4 ACLs, or access control lists. Now, I'm going to sprinkle some things in here to kind of spice this up and to give you some things to think about when you're configuring your standard numbered ACLs. All right, well, let's dive in and take a look at this activity. As you can see, we have the configuration over here on the left-hand side, and we've got our addressing table on the right-hand side. Now, the scenario which the activity actually walks us through is going to have us apply some ACLs, or an ACL on router 2, as well as an ACL on router 3. And again, we're going to refer back to the course text so that we can get the proper placement location, at least from a best practices perspective, a Cisco best practices perspective, with standard ACL. So, step 1, investigate the current network configuration. And this is amazing advice right here. And this is advice that I absolutely recommend that you continue to use even when you move on in your networking career, is before applying the ACLs, check to see if you have the current connectivity that you believe that you have. And so we're going to go ahead and confirm full connectivity. We're going to choose a PC and ping the other devices in the network. Well, as you can see, it's going to be this web server is going to be the key here, and they're going to have us block connectivity from PC2. So let's get PC2 up. And let's check with PC2 and kind of poke around the network and see what we can see. So let's say ping 192.168.20.254. And do I have connectivity right now from PC2, which is on the 192.168.11.0/24 network segment? Can I get to the web server? I can. Let me see if I can get to PC3. So let's go ahead and say ping 192.168. And PC3 is 30.10.30.10. So can I reach PC3, which is this PC right here on the 192.168.30 network? And I can. We don't have any problems at all. So we picked a PC, we pinged some other devices, everything looks good. Now, step number 2. And this is where you would be given sort of the verbal or written requirements for the ACL that you would like to apply, or that your boss is asking you to apply. And you can see here, we're going to implement this policy on router 2. The 192.168.11.0/24 network is not allowed to access the web server on the 192.168.20.0 network. All other access is permitted. And so here's where I'm going to kind of change things up a little bit. We're going to go ahead and we're going to do the ACL like we would. And you can see that we do have ping connectivity, right? We do have connectivity to that web server. And that's what we want to take away. But what we want to ensure that we don't take away, and this is PC1 that I'm pulling up right now, is we don't want to take away PC1's ability to ping the 192.168.20.254, right? So again, we're only trying to impact, and maybe a little drawing tool action here, we're only trying to deny this subnet, in other words, this PC, and theoretically if we had an IP an IP default gateway configured here on switch 2, and we had an IP address in this subnet, switch 2 would theoretically be able to ping the web server, but we're working with the PCs here. So it's going to be the PC2 that should not be allowed to ping the web server. So now the next thing that we need to take into account is, where would this ACL be applied? Do I apply it here? And this kind of goes back, if you watch the previous video, 414, where I walked through the demonstration, we talked about the Cisco best practices for the placement of standard ACLs, and that's irrespective of whether it's a numbered standard ACL or a named standard ACL. It's the standard ACL that drives the Cisco best practice placement of that ACL. And if you remember, when we looked at the course, you can see here that standard ACL should be located as close to the destination as possible. And you might be asking yourself, well, why do I want it as close to the destination? And this right here is going to be your answer. If I put the ACL here and I did it in the inbound direction, right, because the traffic is coming into the interface. It's not egressing, right? It's ingress traffic. It's coming into that interface right here, and I believe that's gig 01. If I put the ACL here in the inbound direction, and it says access list 1, and remember, standard ACLs can only filter traffic based on the source network or source host, right? It's on the source. That's the key. So I would have to say deny, and if we're denying that entire subnet, which is the requirement here, that entire /24 subnet, so from and if we said the usables were going to be from .1 to .254, right? That entire /24 block, if I put that here on that interface, no traffic from this entire network would be able to go anywhere, right? It would get blocked right there. So we don't put it as close to the source as possible. We want it as close to the destination as possible. Well, how would we get it as close to the destination? Would it be here? Well, again, the answer is no, because the traffic would be coming or here. And depending on how EIGRP is going to route us here, if the traffic came this way inbound or if it comes this way, and it should come this way right here, and we could trace that out to see, it should come this way here. If I put the ACL here in the inbound direction, and this is how EIGRP is routing my traffic, then I'm not going to be able to get over here, right? Because again, EIGRP is not routing the traffic this way. It's routing it this way, right? And maybe that's how it's going to get me over here to the 192.168.30. Again, we could trace it out and see, but the idea is that this is going to cause problems if I put it here, because maybe putting it there impacts traffic getting over here. Who knows what the delay on that circuit is? And again, we haven't looked at the routing table. That's another conversation, but you get the idea. So as close to the destination is that interface right there. In fact, let's clear the screen here because we were getting a little noisy. So that interface right there is as close to the destination as possible. And that is where we should place that standard numbered ACL, because then it only impacts traffic in the outbound direction, which would be going to this network or to devices on that network. And the only device we have here is the web server, and that meets both of my requirements. So let's knock that out. And again, that's kind of step 1 here. So we're going to take a look at step A, and then we're going to come down here to step 1, and we're going to go ahead and knock it out and run some validation commands and see what those commands are going to give us. So where's the ACL going to go? It's going to go on router 2 because that is as close to the destination as possible. And again, I keep stressing that because that is a Cisco best practice. Now, do you have to put it there? And the answer is no. And again, use case is going to dictate maybe that's not the best place for it. Maybe the architecture is different. Maybe there are other variables in the equation. But if you can, get it as close to the destination as possible because you're filtering on the source network in this case, right? And again, if we had other PCs down here, I could just deny traffic from PC2 if that was the requirement, right? So there's things you're going to have. It's all about use case, right? What are you trying to achieve? So let's go ahead and get into global config, and let's say access list 1, and we're going to say deny the 192.168.11.0. And now again, this is the wildcard mask, and I'm going to play out here the inverse, right? I'm going to show you what I'm talking about when I say it's the inverse of the subnet mask. Again, just a quick little tutorial here on that. So the subnet mask for this network right here is 255.255.255.0. The wildcard, and I'll say SM for subnet mask. The WM, the wildcard mask, which we are provided with right here, is 0.0.0.255. And you can see it's the inverse. And by inverse, I mean the subnet mask has 255, the wildcard mask has 0. 255, 0. 255, 0. And when the subnet mask has the 0, it's a 255. And so you might be asking, well, okay, can I do it like this? Well, there's actually an even better way to do it, and that is the all 255s. So you just simply put down all 255s. So in other words, 255. So 255.255.255.255. And then you subtract from that value your subnet mask, 255.255.255.0. And it's nice, easy math, and that's where we get our, so we'll say right here, this is the all, and I'll just put A2 for all 255s. That right there is my subnet mask. So I subtract my subnet mask from the all 255s, and that gives me my wildcard mask, my WM, right? So that's how we get that value. And again, I just wanted to cover that again. Introductory CCNA course, and sometimes the masking, both wildcard and subnet masking, can become a little confusing. So that is how you calculate those values. All right, so back over here, we've got the first access control entry, the ACE, right? Like ace of spades, ACE, access control entry. And we have that. Now, here's a common mistake that learners will make. And let's play this through. So I put my deny statement in there. I forget that you need to do a permit any, because what is at the end of the ACL? Is it a permit any that's implicitly at the end of every ACL, whether it's standard or extended, and whether it's named or it's numbered? At the end of every access control list is an implicit deny any. So deny everything unless I'm told to do otherwise, right? So it's going to be as restrictive, the most restrictive as it can possibly be by default and implicitly. And I mean implicitly because right now, if I say do show access list, where is the deny any? And again, it's not there, right? It is implicitly there. We're not going to see it. It's not going to be there, but it's implicitly there. And let me prove to you that that's the case. So I forget to put in the access list one permit any for whatever the case may be. And now I'm going to go ahead and get into interface. And actually we can take a look here. I'll say do show IP interface, IP interface brief, because we're looking for that 192.168.20 network segment, and it's on gig 00. So I'm going to go into interface gigabit Ethernet 00. And I'm going to say IP access group 1, right? The number, and if I were to do a question mark here, we saw this in the 414 video, I can put in the access list number, right? Or I can put in the name. So IP access group 1, and what direction is the traffic traveling, right? It's going to be going out of that interface. So I'm going to say IP access group 1, and let's say do show access list, right? So there we go. Again, the command that I really like, and they actually have it in this activity. I don't see it. It's in here. So it's down here in step 3, actually. So show IP interface, and we're going to pipe it to include access list, right? Oh, sorry, do. Forgot that we are in interface subconfiguration mode. And you can see here, I didn't specify the interface, but we see we've got an outgoing access list applied to one of the interfaces. If I was to change this command and be a little more specific and say gigabit Ethernet 00, you can see, excuse me, that the access list is applied. So remember, we've got this implicit deny any at the very end of the ACL, in addition to the one statement that's in there which is already denying something, right? So let's come back. Oops, sorry. Let's step back over here. So let's come to PC2, and this is typically the mistake that learners will make is they forget to put the permit any at the end, right? Because we want other PCs to get to that web server. It's just PCs on the 192.168.11 that we want to deny. So now from PC2, I try to ping, and I think nailed it, right? I'm thinking, oh, I nailed it. This is great. But does that ACL have unintended consequences? And the answer is it does. Because PC1 is on the 192.168.10. Now it can't get to the web server. What about PC3? Let's bring PC3's window down here. Let's give ourselves a little more room with which to operate. And let's say ping 192.168.20.254. And PC3 cannot get there, right? And so this is where we need to put the permit any at the end of the ACL. So you might be asking, well, how do we do that since we've already created the ACL and we've applied it to the interface? Well, that's not difficult to do. Let's say do show access list. We know the access list number is 1, so let's go ahead. Access list 1 permit any. We'll say do show access list, and we've just added it in there. Now, what's interesting is we've got these 4 matches here. So let's talk about the matches for a second. Now, remember, this deny statement here is denying traffic from the 192.168.11 for PC2. So when I ping from PC1 and I ping from PC3, I don't see any matches because those didn't match this rule. But now that we have the permit any in here, let's rerun the ping and take a look at that. You can see the pings now work. And if I go back to router 2 and we say do show access list, that is where the matches come into play. Let's take a look from PC3. Do we have connectivity? And this is why it's so critical when you're in your environment and you're applying ACLs that you not only test the connectivity prior to the application and the creation of the ACL, but that you test the connectivity from other hosts after it has been applied so that you don't end up with unexpected results, right? Or what, again, Brian McGahan, over a decade ago, I first heard the phrase, a resume generating event, right? You do not want a resume generating event, which is an event where you apply an ACL and you take your entire network down and then your boss says, what are you doing, right? So if I run this again, you can see that is where the allowed traffic, the permitted traffic is matching, but the denied traffic, which we see there, and it's nice we get that message back, right? Telling us destination host unreachable, it's matching here. Now, this is also a reason that you will have, again, at the end of this ACL, there is still a deny any. And if you think of it like this, right? Rule 30 is deny, and I'll do it in cursive here, deny any. But we're not going to get to that rule because we denied what we wanted to, and then we permitted everything else. So we're not going to hit that. And the point that I want to make, though, is this is an instance where we're denying one subnet, but we want everybody else to be allowed. In other cases, you're going to want to allow a subnet or a certain number of subnets, because look at it like this. We could have said, allow the 10 and allow the 30, right? And then leave the implicit deny at the end. But what most people do in that instance, and let me go ahead and I'll show you what I'm talking about here, because this is very important, right? In this use case here, yes, it's easier to simply deny the network that we don't want and then just let everybody else in. But what if it was this? What if I said access list 2 and I said permit the 192.168.10.0/24 and then permit the 30.0/24? Now, when I say do show access list 2, that's what we've got. You'll notice there's an implicit deny any here that we don't see. And this is also I don't want to say it's a Cisco best practice, but this is a security best practice. If you're interested in seeing whether or not that deny is actually being hit, what you would want to do is explicitly say let's get access list 2, deny any. Because if you don't put that in this ACL, all the traffic that's being denied, you're not going to see the matches, right? You might want to know that, because if someone's trying to get to that web server that you don't anticipate, or that you're not expecting to try to get there, in other words, if you've got a bad actor in your network, you want to know about it. And this statement here will help you to identify whether or not that deny rule is getting hit. Because without the explicit configuration of that deny any, you would not see the matches here, right? Now, there's logging that's involved as well, another subject for another time, but this is a good start to get you up and running. So remember that, right? If you want to see if that rule is being hit, the deny at the end here, you need to explicitly put that in there. If you leave the implicit, it's going to achieve the same result, but you're not going to get sort of those the granular details to get you on your way to figuring out, well, who's trying to access the web server and who keeps hitting this deny any rule, right? So again, keep that in mind. Okay, so step 1 is taken care of. We fixed the ACL. Now let's go to step number 2. Configure and apply a numbered standard ACL on router 3. Now, they give us the information that we need. Let's pull router 3 up here. And let's scoot that over a little bit. So they give us all the information that we need. And what are we trying to accomplish here? Well, we're trying to accomplish an ACL. It's going to have number 1, just like it did on router 2. And it's going to deny access to the 192.168.30 network from PC1's network. And again, it's not just PC1, it's the entire network of PC1. So this is going to look strikingly familiar to what we just did. But let's go ahead and let's say ping 192.168.30.10. Again, do I have connectivity to PC3 from PC1? And the answer is absolutely I do. And that's what we want to stop. So let's get router 3 up here. Let's get into, and let's see if we can break out. There we go. Let's get into global config by typing conf t, and let's create that access list. So access list 1, and we're going to approach this from the deny perspective. Again, remember, what could I do? I could say permit things from the 192.168.11 and the .20, and it would achieve the same goal, right? But this is going to be more straightforward, and this is what they're actually looking for us to do. So access list 1 deny 192.168.10.0, and then there's that wildcard mask, the inverse of the subnet mask. And what does it say? We want to permit all other traffic. So access list 1, permit any, because at the end of every ACL, and I'm trying to drive this point home with you because this is the number 1 aspect of access control lists that learners will overlook. And that is that implicit deny any at the end. All right, so let's say do show access lists. And there's our ACL. Everything looks good. Let's get into int gig 00, and let's say IP access group 1 outbound, right? So we're doing the exact same thing that we did on router 2, blocking one network segment. And now let's go ahead and take a look here. Do the pings work? No. We get destination host unreachable. And again, if you're keeping track of the completion percentage down here on the right, it's very tiny. It just says completion percentage 100%. So we're done, but let's take a look at this. So they've got these different pings that we should be testing. So can I ping 192.168.11.10? Absolutely, that works. Can I ping 2254? And absolutely, that works. Remember, we blocked PC2 PC2 from getting to the web server. So PC1 can still get there. And we already tested the PC2 ping to the web server, the 2254. That failed. What about from the 10 to the 30? We just tested that. That fails. What about from the 1110 to the 30? And let's pull this back up. And so I'll say 30.10. And that's going to succeed. And then finally, we're going to go to 2254. And actually, I think I had that queued up in there. Wait a second, I'm on the wrong PC. From 30.10, I apologize. I was on the wrong PC there. And let's go to 2254. And that is going to succeed. And again, how do we see the ACLs? We can say, show access lists. Oops, sorry, we don't want router 1. I want router 2. So it's going to be show access list. And that's going to show me all my ACLs. It's going to show me all of my, all of my matches that could be taking place. And on router 3, same thing. Let's say end and get out to privilege exec and say show access list. And there we go. And again, my go-to, specifically when I'm troubleshooting things, is I want to look at the interface, show IP interface gig 00, and then include access space list. Right on the interface, it actually says access space list, not access dash list. And that's quickly where you can determine, hey, is there an ACL on this interface? Maybe that's causing my connectivity issues, right? It's a great way to dig in and take a look. And you'll notice there's that show IP interface command. Again, that is my go-to. I love this command. Very effective for troubleshooting. All right, well, that is our first foray into a scenario where we have multiple access control lists with multiple access control entries, and we're applying them on multiple routers. So that is going to do it for this packet tracer tutorial on activity 5.1.8, where we took a look at configuring numbered standard IPv4 ACLs. Most importantly, remember, best practice, get that ACL as close to the destination as possible, right? Because you can only filter on the source address, and you don't want to filter on the source really close to the source, because as we saw, you might end up filtering traffic that is okay, that's supposed to go to a different network segment in your environment. All right, thank you so much for watching. Best of luck to you in your studies, and I hope to see you in the next video.